So we're looking for vertical asymptotes and or holes, if there are any. These are both types of discontinuities in a rational function. We look to the denominator, and let's look at the first example. The first example, we set the denominator equal to 0 and solve, get x equals 2. Because the numerator does not have a common factor with the denominator, x equals 2 is our vertical asymptote. And there are no holes. Example number 2 has a vertical asymptote and a hole. So let's look at it so we can see the difference. X over x, that's what we're looking for a hole. X equals 0, x plus 4 equals 0. This is a hole, and then subtract 4 on both sides. X is negative 4 is the vertical asymptote. Remember, this common factor produces a hole. Alright, so let's look at number 3. Number 3, the numerator does not need to be factored, but the denominator does. Stop the video if you need time factoring that. This is going to factor into x minus 6, x minus 1. We see a common factor. This is going to produce a hole. It's going to produce a hole when x equals 6. The other factor, which is the x minus 1, that's going to produce your vertical asymptote. X equals 1 is a vertical asymptote. Okay, last one. Again, the denominator does not need to be factored, but the numerator does. So I will go ahead and factor the numerator. Stop the video if you need help factoring. And if we look, that's going to produce a hole. Just like before, this is the hole. X plus 6 equals 0. So the hole is going to be at negative 6. Now, the x plus 5 here is in the numerator. So this does not create a point of discontinuity. So there is no vertical asymptote. So now we're going to do the horizontal asymptotes of rational functions. There are 3 rules, and you need to memorize these. There is some explanation if you want to go deeper, but that is for another video. So you look at the degrees of the numerator and the degree of the denominator. That's what the little n and the d represent. So you compare the degrees. If the degree of the numerator is less than the denominator, aka larger on the bottom, y equals 0 is the horizontal asymptote. If n equals d, then you go to the coefficients of each polynomial, the numerator and the denominator, and that becomes the horizontal asymptote. And if it's big on top, n is greater than d, then there is no horizontal asymptote at all. And we'll look at that case in just a minute. So the first example, we see that the numerator is degree 1 and the denominator is degree 2. So this one's big on bottom. And so the horizontal asymptote is going to be y equals 0. Example 2, they are the same. The degrees are the same. So we're going to look at the coefficients. So the coefficients are 12 over 9. This is a fraction that can be reduced, so let's do that. And that's going to give me 4 over 3. So the horizontal asymptote is y equal 4 over 3. Example 3, it's big on top. The numerator is greater than the denominator, and so there is no horizontal asymptote at all. Now, example 4 is the same situation. It is bigger on top, but it is bigger on top by 1. It's bigger by 1, and we're going to move into this. The next slide we'll talk about this situation explicitly. It's bigger on top by 1 degree. So there is no horizontal, just like we decided, but because it's bigger by 1 degree, this one has a slant or an oblique. We're going to talk about obliques on the next video.